Hello, 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 and welcome back to Shiksha DaCosta. Today we're going to start a unit called Graphs of Quadratic Relations. In the first part of this unit, we're going to learn to determine what the basic properties of these relations, these new relations that we're going to learn that are called quadratic. What are those properties of them? And there's a whole bunch of stuff that we're going to do to ascertain those. We're also going to relate the transformations of a graph y equals x squared, and we'll learn that this is actually a quadratic relation. We'll compare the graph of y equals x squared to y equals a times x minus h squared plus k, where a, h, and k are all different numbers. So in doing so, we will relate the graph of y equals x squared and all of its transformations. To get started with this unit very quickly, I'm just going to ask you this quick question here. Is this fair? If you were going to a pizza place and you saw that a 5-inch pizza was $4, a 10-inch pizza was $15, and a 15-inch was $35, would you say that's fair? You can pause the video here and think about this for a minute. Once you have your answer, just click play. Well, some people might say, this doesn't really seem fair. Look, the 5-inch to 10-inch, that's only twice the size. But the price, 4 times 2 would get me 8. $15 is almost 4 times the price. And if I go from 10 to 15-inch, well, that's 1.5 times as big. But the price does not get 1.5 times. It gets more than doubled, right? 15 times 2 will get me 30, and this is 35. So these prices do seem to be out of whack. But when you start to look at the actual pizza, a 5-inch radius pizza might look something like this. Its area would be 78 square inches. A 10-inch pizza would look something like this. Now, doesn't this look a whole lot bigger than this? More than just 2 times? In fact, the area of this pizza would be about 314 square inches, and the area of a 15-inch pizza would be about 707 square inches. Look how much bigger that is even compared to this. If we divide these two numbers, we'll find out that the area got multiplied by about 4, which is much more in line with our price increase than it was with our size increase from just the radius of the pizza. And as we go from a 10-inch pizza to a 15-inch pizza, the area gets multiplied by 2.25 approximately, which is much more than just 1.5, which we thought it would be. These price increases are much more in line with the actual size increases of the pizza when we consider the area of the pizza that we're going to get. And this sort of relationship that is not increasing in a linear way, it's like just an extra 5 inches, just an extra 5 inches, but the price gets multiplied or gets bigger and bigger. The difference is here, I think it's $11, and from here to here, it's $20. So it's going up faster and faster in price, even though the radius is increasing by the same amount. This sort of relationship is not what we would call a linear relationship. Linear relationships, like y equals mx plus b, that's the equation of any straight line, they always increase or decrease at a steady rate. So you can see here this red line is going up, and it's always going up by a steady amount. So if you go to the right by, let's say, 3, and then you go to the right by another 3, both times the line will go up by the exact same amount. Or if it's decreasing, for example, if you go to the right by the same amount each time, the line will go down by the same amount each time. But not everything is linear. Not all things we encounter in life are actually related in a linear fashion. Sometimes when we increase one quantity, the other one doesn't increase by the same amount each time. It increases faster and faster and faster. And one of these types of relations, there are very, very many that are nonlinear. One of these types is called a quadratic relation. And the equation of a quadratic does not look like y equals mx plus b. The equation is actually y equals ax squared plus bx plus c. And there are a few different equations that are quadratic, but all of them have one thing in common, is they have an x squared term. And the reason we call these relations quadratic is because the Latin word for square is quadratum. And they're the folks who came up with the name for this sort of relationship. Now, we have a lot of work to do in this unit when it comes to quadratics, and it really starts with some really solid algebra skills. So please make sure you brush up on those before you dive into quadratic relations. If you like this video, please like, rate, subscribe, and join our mailing list. And you can find this lesson as well as practice questions, solutions, handouts, and more on our storefront. Thanks and have a great day.